Okay, so let's talk about biodiversity. So we asked you to define it. Looking here, we talked about species richness and species evenness, right? So both of these are the same richness. They have the same number of species, but this one is much more even. We have 4 of each rather than this disproportionate distribution. And again, I mentioned in there that if these were at all different levels of the trophic structure, you would expect it to be uneven. But we're talking about sort of at the same trophic level, how many species do we have and how dispersed are they? How even are they? Okay, so those are the 2 things that we look at. And then we looked at different things that affect the diversity index. So I'm just going to go through these graphs, each of them. So here we're looking at, these are plots of grassland, and this dark line, the solid line, they introduced just 3 species. The dotted line, they introduced 10 species, and the dashed line, they introduced 30 species. And so what you should be looking at is from 0 to 100 in density. That this one goes up way more as far as the species richness. So having more species there seems to promote other species growing. And just think about it, right? We have resource partitioning where they're using different parts of the environment and they're giving off different waste products, and maybe some of them thrive off the other ones. And so having more diversity can actually increase your species richness. But once we get past 100, having lots and lots and lots tends to decrease, right? Then we get competition between the organisms, and so you lose them over time. So more diversity does promote more diversity, but too much density, and you're gonna lose diversity. This one here is they were looking at a lake and the amount of bacteria, and this is basically just the area of the lake versus the number of bacteria species. And obviously, as the lake is bigger and there's more room, you're going to have more species. So that one's kind of an obvious one. This one here was not as obvious as it may seem, and that is they looked at these populations where there were no predators versus where predators were introduced. And so the pinfish was an omnivore. The crab kind of specialized on one particular species, but these guys are generalized predators. And you notice that more predators actually increases species diversity. And that's because, think about Yellowstone and what you learned about that, right? When we remove a keystone predator, some of the organisms that they eat all of a sudden get this boom in population size, and they can actually outcompete other organisms. And so you need that balance of the predators. So adding predators to an environment can actually increase species diversity. This one was looking at temperatures versus diversity, and so obviously the warmer temperatures, if we're in more tropical regions versus temperate regions, you're going to get more diversity. The more warmth you have, the more sunlight you're getting in, the more energy you have available for trophic levels. This one is looking at elevation. Again, pretty obvious. As you go up in elevation and it gets colder and drier and less nutrients, you're going to have less diversity. This one is not as obvious also. This one's an interesting one. And this is disturbance. So how many times we've destroyed parts of the reef. This was a coral reef. And you would think that you don't want disturbance because that would kill off species. But it turns out if you don't get a little bit of disturbance, then you get some species that just take over and establish themselves. And it's hard to overturn them and get more diversity. And so the most ideal for diversity is actually a decent amount of disturbance. So an average amount of disturbance. Too much disturbance, again, you're going to kill off species, but you want a little bit of disturbance for diversity. And this one is looking at nitrogen deposition. So this is eutrophication. So and this is counterintuitive too, right? You would think if there's more food available, then there should be more species diversity, but that's not true. To a certain extent, higher temperatures, lower latitudes, you will have more nutrients in the system. But if you get too much nutrients in the system, it'll actually crash the system because you'll get eutrophication. You'll get one trophic level, one organism that will have this huge boom and outcompete others, and the ecosystem can collapse. And so more nutrients is not necessarily better. And then this one here, they're looking at the types of habitats that are in the given environment, and the more differences there are in different types of habitats in the same area, obviously the more diversity you have, right? The more niche partitioning you can get where they can all use different things in the environment. And so that's summarized here. I just wanted you to see how we got it from the graphs.